Good day everyone, welcome to this tutorial of solving confidence interval problems in medical trials. Today, we explore how to determine the confidence interval for the difference in mean blood pressure levels between two groups of patients, each treated with a different medication. Understanding this process is crucial in evaluating the effectiveness of medical treatment.
Let's consider a real-life problem scenario that is inspired by a study comparing Losartan and Atenolol, which are both used to treat high blood pressure. Which drug is more effective in reducing systolic blood pressure? For our group 1, we have the Losartan. The sample size is 100. The mean is 130 millimeters of mercury, and for the standard deviation, we have 10 millimeters of mercury. For the group 2, we have the Atenolol, which has 100 sample size, 135 millimeters of mercury for the mean, and a standard deviation of 12 millimeters of mercury.
Estimate the confidence in interval for the difference in mean systolic blood pressure level between the two groups. So within this data, we want to estimate the confidence interval of the difference in mean systolic blood pressure level between the two groups. In other words, how much better? On average, it's one medication over the others. Also, how confident can we do about that difference?
We'll calculate the 95% confidence interval for the difference in means. Using this formula, confidence interval is equal to the quantity of the x bar sub 1 minus x bar sub 2 plus or minus the z multiplied by square root of the quantity of s sub 1 squared over n sub 1 plus the quantity of s sub 2 squared over n sub 2. Wherein, in this formula, we have the following given variables. The x sub 1, the x bar sub 1 and x bar sub 2 are the sample means, and s sub 1 and s sub 2 are the standard deviations. The n sub 1 and n sub 2 are the sample sizes, and the z means the z-score for 95% confidence, which is 1.96. From our problem, we have the following given. X bar sub 1 is equal to 130, x bar sub 2 is equals to 135, s sub 1 is equals to 10, s sub 2 is equals to 12. Both n sub 1 and n sub 2 are 100, and the z-score for the 95% confidence is 1.96. By plugging these values into the formula of the confidence interval, we have this calculation. This is the complete solution. The confidence interval is equals to -5 plus or minus 3.06.
This gives us a confidence interval of approximately -8.06 and -1.95. This means we are 95% confident that Losartan lowers systolic blood pressure by 1.94 to 8.05 mmHg more than atenolol. In conclusion, our confidence interval does not include zero, which suggests a statistically significant difference between the effects of Losartan and atenolol. Clinicians can use this information to make informed decisions on which medication may be more beneficial for patients.
Thank you for watching. Confidence interval offer powerful insights in medical research, helping us bridge data with decisions that improve and, mostly importantly, save lives.